Pluto, the tiny and mysterious world located on the outer edge of our solar system, has captured the imagination of generations of people. For decades, Pluto was the ninth planet, nestled in the far reaches of the solar system, until its status was abruptly revoked in 2006. This decision was a controversial one, sparking heated debates, protests, and disappointment among those who had always considered Pluto a true planet. For many, Pluto's demotion left a feeling of sadness and disbelief. After all, Pluto had been with us since the 1930s, and it had always been included in the solar system as a planet, despite its small size. However, even though its planetary status was stripped, the world's fascination with Pluto never faded, and recent discoveries have only intensified the mystery surrounding this distant dwarf planet. NASA's New Horizons mission to Pluto, which sent back astonishing data and images, revealed a side of Pluto that no one expected, leading to a wealth of new questions and excitement. The year 2015 marked a pivotal moment in our understanding of Pluto when NASA's New Horizons probe made its historic flyby of the dwarf planet. For the first time, humanity received real, detailed images of Pluto, breaking the long-held view of the planet that had existed for decades. Prior to this mission, the only images people had ever seen of Pluto were artistic depictions, which showed the planet as a cold, barren rock on the edge of the solar system. There were no clear images of Pluto's surface, and our knowledge of it was limited to theoretical models and blurry data. But when the New Horizons spacecraft arrived at Pluto and sent back the first close-up images, the scientific community was stunned. Pluto was not the featureless, frozen world that had been imagined. Instead, it was a dynamic, complex, and active world with surprising geological features, including mountains, icebergs, deep canyons, and vast plains. These images completely turned our understanding of Pluto on its head, leaving many people in awe of the planet's true nature. One of the most shocking and fascinating aspects of the New Horizons data was the discovery of a massive, heart-shaped region on Pluto's surface, which has come to be known as Sputnik Planitia. This area, stretching over 1,000 kilometers, is a vast icy plain made of nitrogen ice with some methane and carbon monoxide mixed in. What makes this region so unique is not just its shape or its size, but the fact that it is part of a much larger, dynamic geological process that is still ongoing today. Sputnik Planitia is not a static feature, it is constantly being reshaped by Pluto's internal heat, which drives geological activity beneath the surface. Scientists believe that the heart-shaped region is actually a giant impact basin, the result of a massive collision billions of years ago. But what makes it even more interesting is that it has been altered by cryovolcanic activity, a process in which volatile substances like nitrogen and methane erupt from below the surface, creating icy mountains and valleys. The existence of such processes on Pluto raises the question of whether the planet might have a warm core, perhaps even an underground ocean of liquid water, hidden beneath its icy shell. One of the most astonishing findings of the New Horizons mission was the evidence that Pluto's surface is far from dead. For years, scientists believed that Pluto, being so far from the Sun, would be a frozen, inactive world, incapable of geological processes. However, New Horizons revealed a much more vibrant and active Pluto than anyone could have imagined. The probe captured images of large icebergs drifting across Pluto's surface, their movement suggesting that Pluto's surface is constantly being reshaped by internal forces. These icebergs are made of nitrogen ice, which is much more volatile than the water ice we are familiar with here on Earth. The fact that these massive blocks of ice are gliding across the surface of Pluto raises important questions about the planet's internal activity. Scientists now believe that there may be a nitrogen reservoir located several kilometers beneath Pluto's surface, which is responsible for pushing the icebergs and other surface features upward. This process is likely driven by the planet's internal heat, which has led to the creation of bizarre geological structures, including the honeycomb-shaped patterns that cover parts of Pluto's surface. The presence of these icebergs and the evidence of geological activity suggest that Pluto is far more geologically active than scientists previously thought. The discovery of these dynamic processes challenges our understanding of planetary formation and evolution. Pluto's internal heat, which was once considered impossible given its distance from the Sun, is now seen as a key factor in driving its active surface. Researchers believe that the planet's core may be warm enough to maintain a subglacial ocean or even cryovolcanic activity, which could have profound implications for our understanding of how planets and moons evolve. This new information about Pluto's geology has sparked renewed interest in the planet, with scientists eager to learn more about its internal structure and the forces that drive its geological processes. The discovery of these features has also led to speculation about the possibility of life on Pluto. While it is unlikely that life, as we know it, could exist on Pluto due to the extreme cold and lack of liquid water on the surface, the idea of life existing beneath the surface is still a possibility. Researchers believe that there may be pockets of liquid water trapped beneath the icy crust, where heat from Pluto's core could provide the energy necessary to support some form of life. This is similar to the conditions that exist on some of Jupiter's and Saturn's moons, such as Europa and Enceladus, which are believed to have subsurface oceans where life might exist. While life on Pluto remains speculative, the possibility of a subglacial ocean and the dynamic processes happening beneath the surface of the planet has opened up new lines of thought about the potential for life in the farthest reaches of our solar system. Another fascinating aspect of the New Horizons findings is the discovery of Pluto's unique atmosphere, which is composed primarily of nitrogen, methane, and carbon monoxide. The thin atmosphere of Pluto is highly dynamic, changing in response to the planet's position relative to the Sun. As Pluto moves closer to the Sun in its elliptical orbit, its atmosphere expands slightly, causing some of the volatile gases to escape into space. When Pluto moves farther from the Sun, the atmosphere condenses and freezes onto the surface, a process that creates dramatic seasonal changes. These seasonal variations are not only visible in the atmosphere but also in the surface features of Pluto. The snow that falls on Pluto is not made of water, as on Earth, but of frozen nitrogen and methane, substances that are much more volatile than water ice. This exotic snow reshapes Pluto's surface, covering it with fresh deposits and causing the ice to move in a manner similar to glaciers on Earth. The discovery of snow on Pluto is just one example of how the planet's surface is constantly being renewed by atmospheric processes. These seasonal cycles are intricately linked to the changing density of Pluto's atmosphere, which causes dramatic shifts in surface features over the course of its long orbit. The changes in surface brightness and the distribution of icy deposits suggest that the entire surface of Pluto is shaped by these atmospheric cycles, with fresh layers of snow and ice constantly being deposited and reshaped. This dynamic process means that Pluto's surface is far more active than previously thought, and the planet is constantly undergoing geological and atmospheric changes. Perhaps one of the most iconic features of Pluto is its heart-shaped region, Sputnik Planitia, which has become a symbol of the dwarf planet. This large, smooth region is composed mostly of nitrogen ice, and its stark contrast to the darker regions surrounding it has made it one of the most recognizable features of Pluto's surface. The heart-shaped area is part of a much larger geological structure, and it is believed to be the result of a massive impact that created a large basin. This impact may have been followed by volcanic activity that reshaped the region, making it one of the most geologically interesting parts of Pluto's surface. Sputnik Planitia is also the location of some of Pluto's most dramatic surface features, including large icebergs and vast plains of frozen nitrogen. Scientists believe that the region's smooth, flat surface is constantly being renewed by internal processes, and the possibility of a subsurface ocean beneath the ice sheet only adds to the intrigue of this remarkable feature. Pluto's moon, Charon, plays an important role in the dynamics of the Pluto-Charon system. Charon, the largest of Pluto's 5 moons, is about half the size of Pluto itself, and the two bodies are gravitationally bound in such a way that they always face each other. This unique relationship leads to tidal forces that affect both Pluto and Charon, potentially driving geological activity on both bodies. Some scientists have even suggested that Charon may not be a true moon but rather a dwarf planet that was captured by Pluto's gravity long ago. The gravitational bond between Pluto and Charon creates a complex interaction between the two bodies, with tidal forces causing shifts in both their surfaces and their internal structures. These forces may be responsible for the heat within Pluto's interior, which drives the geological activity that we see on its surface. the dynamic relationship between Pluto and Charon has profound implications for our understanding of the two bodies. The tidal forces between them could influence the composition and structure of their surfaces, potentially leading to the creation of new features over time. For example, the gravitational interaction between Pluto and Charon may have caused the movement of icy materials across Pluto's surface, leading to the formation of the large icebergs and the strange geological structures that New Horizons observed. The influence of Charon may also be responsible for the existence of Pluto's unique atmosphere, which is heavily influenced by the proximity of its moon. While the possibility of life on Pluto remains uncertain, the new findings from the New Horizons mission have opened up exciting possibilities for future exploration. The data returned by the spacecraft has revolutionized our understanding of this distant world, revealing that Pluto is far more complex, active, and intriguing than we had ever imagined. From its icy mountains and vast plains to its dynamic atmosphere and strange geological features, Pluto continues to surprise us with its many mysteries. As scientists continue to study the data from New Horizons, we can only wonder what other secrets Pluto is hiding, and what new discoveries await us in the future. The more we learn about Pluto, the more it becomes clear that this small, distant world is full of wonders that challenge our preconceived notions of what a planet or a moon should be. With its heart-shaped ice plains, its wandering icebergs, and its enigmatic atmosphere, Pluto is not just a tiny, frozen rock at the edge of the solar system. It is a vibrant and dynamic world with a story to tell, a story that is still unfolding. And with each new discovery, we come closer to understanding the true nature of Pluto, a world that continues to captivate our imaginations and inspire awe.